Hi, I wanted to do a short cast about programming languages and two of the programming languages that I think are very worth investing some time learning uh, these days. So they are F Sharp, a language for the .NET framework, and Clojure that runs on the Java virtual machine. So both of these languages are so-called functional languages, and it's not a surprise because I personally really like the idea behind functional languages. So in case you haven't heard about them, they are not as popular as imperative languages, which is traditionally languages that are opposite of functional languages. A functional language is a language where at least it has a few properties. The first one is that functions are considered first-class citizens, and by that it means that whereas you have types like strings, integers, floats, that are first-class types. A function in a functional language is also a first-class type. So you can create a function like inline, like inside your code. You don't have to create a new block for a function, which is typically what is called a lambda function, which is a anonymous function. So for example, if you have an UI application the need for a callback, instead of having a callback implemented as a method of your object, you could write the method or the callback right at the place where it's passed in to the registration function. Right. So this is one advantage of having functions as a first class type. But also in a functional language, a function can take like this registration function. A function can take a function as a parameter and also return a function. So this level of composability enables higher abstractions than a simple function that takes a scalar type, regular type. Right. So for a very common example is the map high order function. Let's consider that you have a container. So for that purpose, any container will do, whether it's a list, a stack, or a vector, just a container of items. And you want to apply a given function on every item of that container, and then return a similar container, so a container of the same type, but with the items transformed, so new items. So this is what map would do for you. It would take the container and the function, the mapping function, and that map function will return a new container with every item inside applied to the function, to the function you passed. Right. So this is a very interesting example actually, because not only the type of the container does not matter, but also the function is generic. You can pass any function as long as it maps from one the type of item to another type of item. So you don't even have to have the same type in the container. So it could be a list of integers that you're transforming into a vector of double. So this is one thing. The second thing for a functional language is that there's a emphasis on having immutable types. So an immutable type or immutable variable is any variable, any value, let's say, which does not change once it has been set. So this is actually quite the opposite of what you probably are used to in an imperative language. Whereas in imperative language, you have many constructs where you define a variable. Let's say, for example, I equals 0. That defines a variable I. Let's say int I equals 0. That defines I of type integer and assign the value 0 to it. Once you have done int I equals 0, you are free to do I equal 1 or I equal I plus 1. So by doing that, you would change the value of I, setting it to 1 or incrementing it in the second example. In a functional language, most of the time this is not allowed. Once you do I equals 0, I equal 1 will be an error, because as far as functional languages are concerned, let's say just FL are concerned, the I equals 0 is a definition. You define I to be 0. So I equal 1 is a contradiction. Right? I cannot be 0 and cannot be 1. So what's the advantage of that? So far, it seems like it's more like a restriction than anything else. Right? The advantage of precluding reassignment is mostly regarding multi-threaded programming. So that's why functional languages, which are definitely not a new breed of language, they have been around for a decade at least, they are getting more traction, more popularity. So it's still very faint. Not too many users of programmers of functional languages out there. But I feel like it's growing, and I think it's related to multi-threaded programming, because in the past few years, there's been a clear trend towards having systems that have multiple cores or multiple processors or even both, right? And that's related to the fact that processors are not gaining in speed, in raw speed themselves. Before, we could expect a much better performance every generation, usually twice, 2x, 3x for the same price point every few years. And it's not the case anymore. We are now with processors that are about the same raw speed. So raw speed being the speed of one CPU, one core. But we have many of them in a single core. So it's a economy in scale. Right? For the same price, instead of having one very powerful CPU, you would have several not as powerful CPU. So now it's the burden of the programmer, of the software developer, to engineer their software to leverage these multiple cores. And a traditional imperative language is not well suited for that task. And the reason, in my opinion, is that when it comes to programming multiple threads, so using multiple threads in an application with an imperative language, the tools that are given to manage the resources are rather basic. They are still the same as they were a few years ago, basically related to locks, so mutexes, queues, semaphores, these synchronization primitives. But these primitives are still very basic. Right? They are error prone. It's quite common to miss a lock, or to lock and forget to release, or to lock out of order. Right? Either of these mistakes can have a very serious impact on the software. It can lead to data corruption, to freezes, to hangs. Right. So definitely, it's still possible to only use that, but it seems very artificially difficult. Right? And this is kind of baked into the imperative language, because for an imperative language, every statement like I equals 0, I equal 1, so on and so forth, they are statements to your program. In your program, you're telling the program what to do. You're saying that for this particular function, these are the steps that have to be carried out. And by doing so, you are isolating the function, the flow of the software to one sequential thread of execution. This is the natural, basically, flow of your program. And when it comes to using multiple CPUs, you are obligated to start multiple threads, and there is nothing in your visual structure of your program that shows really that you have multiple threads running on the same code. It is by convention, by discipline, that you will know that, okay, this is a function, maybe because you have used some coding convention, or you have yourself created some containers for these callback threads, these functions, and these are the this is how you make sure that people who read your code, either other developers or even yourself, will do the proper synchronization. And once again, without that synchronization, your software would not work. It will at best it will not work. At worst, it will silently work, but then sometimes completely crash. Right. So in the back to the functional language, a functional language tries to work around this limitation by saying that one of the main reasons why you need to synchronize a resource, and the biggest resource to synchronize is memory. One of the biggest reasons you have to synchronize a resource is because you are changing that resource. Right? You are changing a resource, and you want to make sure that other threads, other parts of your application, are not using the value that was there before the change, or at least that they are aware that the change is happening. Right. So a mutex, a lock, will prevent other threads from accessing that shared resource while the current thread is doing something with it. Right. And obviously that's because you are doing something with it. You are changing the value, right? If you were not changing ever the value of anything, after of course it has been constructed, but it doesn't matter that another thread is using the value. And actually it's a good thing, because by increasing the sharing of these resources without locking, you are improving the performance. Right? The same memory is reused by multiple parts. Therefore, you don't have to calculate that value. Right? So this seems too good to be true, right? Well, what good is it for you to have a language where you cannot change any value? Then once it's set in stone. Right? It seems just too much of a limitation. Right? And it's true that it takes a long time. Well, I guess some people it's faster than others, right? It gets some time to get used to the fact that this is what you have to do. You have to abide by these rules, right? So also that means that whenever you need a new value, you have to create a new variable. Right? You cannot do I equal I plus 1. You have to create j equal I plus 1. So a new variable. Right? and it's then the goal, no, the job of the garbage collector to detect what values are no longer needed and reclaim that memory. So there is another, well, you can still leak memory. You can still make software that is spaghetti code that is full of bugs, very difficult to understand and so on and maintain and so on and so forth. But if you follow the rules, right? And these rules are pretty simple. If you follow the rules and you buy into the spirit, then in my experience, it is much easier to write multi-threaded programs that are correct. And once they are correct, it's another step to make it fast. But usually, making correct is a bigger step. So this is my selling pitch for functional languages. Right? Functional languages make programming multiple threads, multi-threaded applications simpler. Right? And there are many examples of programs like that out there. Right? So now that being said, which languages to use? There are still plenty of them, right? And the reason why I picked up these two, F# and Clojure, is because they represent two of the two common platforms. Right? If you work on the JVM, and you would and JVM Java is obviously the very, very popular, if not the most popular language out there. You will have this very strong virtual machine, the JVM, very optimized and very stable. So having a language, functional language that leverages the JVM is the definitive plus. So you have basically two languages out there on the JVM that are functional. You have Clojure and you have Scala. Right? Clojure is a dynamic language in the sense that it's a language where you don't define your type in advance, and it's a language that's Lisp based, based on Lisp. Right? So it's usually much more condensed than language like Scala, which is closer to Java. So Scala is like Java, what Java would be if it was functional, and if you could squeeze the syntax and remove everything that is not absolutely necessary. So it has a very strong typing inference engine, which is capable of inferring the type of nearly anything. Well, okay, not everything, of course, but much stronger than Java. Let's put it this way. For example, you never have, well, you rarely have to explicitly type your variable, because based on the type of the expression, the compiler would manage to infer the actual type. Whereas in Clojure, the type is purely dynamic. That it's also similar though, in the sense that you have a functional language, but the way you use these languages is very different. Clojure promotes the repo loop, the repo, which is a read eval print loop, whereas where you program, you write your functions, and when you see that the function does what you want, you copy that into your code, and then you work on the next function. So it's a very interactive approach to programming. You have a task. You imagine that you have a task, you don't have to work on defining types, defining classes, interfaces, and so on and so forth. You think of a way to represent your type. Usually you map that into a hash, and then you start creating functions that will do the job for you. Right? And as these functions get implemented, you bring them back into your code. Right? So it's a dance between your editor and your repo loop. And there are actually some editors that integrate this loop together. So your editor and your evaluator, they kind of work together, right? So you write code, and as you write the code, the editor evaluates your expressions. So if you are used to a Lisp language, you're probably very familiar with what I'm trying to talk about, right? If you're not, if you're more like from a compiler background point of view, then it may sound kind of strange to have the editing and running your code intertwined like that. But anyone who's familiar with also interpreted languages like Perl probably likes this coding style. It's called a dynamic language because well, it's not really I think the reason, but for me it's called a dynamic language because it's very very dynamic in the way you use it. So on the other hand, you have F Sharp. F Sharp runs on the .NET framework, and it's also a functional first language, but it has a lot of object-oriented features into it. Right? So it's more like a gateway towards functional languages, if I must say that. It integrates very well with the .NET framework, so you can use any of the libraries that are available on the .NET framework. And by the way, Clojure can do the same on the JVM. Right? So you can integrate with any Java library that's running on the JVM. F Sharp would do that on the .NET framework. And also, it would work very well with other frameworks that require you to think in terms of objects. So the one I have in mind is WPF. WPF is a very common framework for UI development, and that's actually the reason why I'm using F Sharp on .NET. The Clojure for me is a perfect language to do the backend prototype and even like backend code. And for the front end, I use F Sharp, integrating with WPF and some C Sharp for the code behind, but mostly F Sharp. So the integration between F Sharp and the .NET framework is so good that I do not miss any features from C Sharp. For me, F Sharp is actually C Sharp, just better. And that's it. Those are my two favorite languages now. I haven't seen any reason to go back to a non-functional language, because actually these languages are practical in the sense that they don't force the functional paradigm down your throat. There are cases where having a mutable variable is just simpler. It's just, for example, if you do a loop in a functional language, doing a loop is like not possible, because if you do a for I equals 0 to 10, you're changing the loop variable. Right? You're changing I from 0 to 10. Right? In a functional language, this construct is turned into recursion. So if you have a pure functional language, you would have this recursion instead of a loop, which seems to be, in my opinion, a little bit too much, basically. Right? So either Clojure or F Sharp lets you have imperative code from time to time. It's obviously up to you to draw the line where it makes sense. But to me, they're all they both work very well because of this pragmatism. Right? They bring functional capabilities to their respective environment, to the JVM or to the .NET framework, while integrating with their support platforms. Right. So there is another language, and I think it's a language also very worth learning, Haskell, which is much more pure in terms of functional language. It is a language where you would not have a loop, you would have a recursion instead, and it has its own environment. So, for example, to learn functional language, maybe Haskell is a better choice because you cannot be tempted to revert to your imperative habits. They just do not exist in Haskell. But unfortunately, it takes a little bit of time to switch away from all the libraries that exist out there, right? So Haskell would have it compares to native, and it has a very large ecosystem. It has a very large third-party library, set of libraries contributed by many developers. But this is going to run on its own platform, right? This is not something that you can find integrate with a Java library that you like or with a .NET library that you like. Well, in conclusion, I would say that it's for me still a little bit unfortunate that you cannot have F# running on JVM and you cannot have Clojure running on .NET, right? Running F# on JVM just doesn't exist. There's no compiler for that. And running Clojure on .NET is fairly unsupported at the time. Right? There's a ClojureNet project, but it's not at the same level of maturity as Clojure on the JVM. So clearly, I would not say that it's production ready. I don't think they say it's production ready either. So there is still this segregation. If you want to do F#, you have to be on .NET, and if you want to do Clojure, you have to be on JVM. But fortunately, these are both very, very good options for their respective platform. And if you have to work on .NET, then F#. It's not like by taking F#, you have a very poor language. It's also a very fantastic language. Unfortunately, it's not a dynamic language. You're not going to be doing the same level of interactive programming that you would if you were working in Clojure. And likewise, if you are working with Clojure, you would not have the constructs that F# has, like discriminating unions, or what else do they have? They have tuples. They have integration with monads, right? They have computation expressions. They have async workflows. So all these things are not coming out of the box in F#. There are libraries for that in Clojure, but for Clojure, it's not baked in, right? Well, that's all I had to say. Okay, thank you.